Ladies and gentlemen, this is an EFI aircraft, electronic fuel injected aircraft. Same principle for global hydropower as its technological system is carried from one application to the next. We use the hydrogen feed line, which will enter into the air internal combustion engine. The EFI injection will be controlled by an electronic computer system which will allow the hydrogen injection to work with the throttle position opening. According to throttle position opening, the injection will be varied, and according to requirement, the hydrogen injection will be varied. Again, simplistic in mechanical application, highly beneficial. Now the feed line, once again, will pass underneath the aircraft and we come down to a compartment in the aircraft. Continuing the global hydropower technological system simplicity, we once again use a hydrogen regulator, two-stage unique to global hydropower, for control of the decreasing volume in the cylinder. The regulator once again takes the gas pressure down from 200 bar to 10 bar, which is a comfortable and safe working pressure. In this particular aircraft, we're looking at using a 1200 litre cylinder. It's a larger aircraft, and this is a 1200 litre cylinder. Unique to hydrogen, we note that the connection to the cylinder is a left-hand thread. There cannot be a mistake when connecting the cylinders. Yes, we acknowledge that the hydrogen cylinders are red, which means hydrogen, but so there's no error. There's a left-hand thread. Other gases cannot be connected through. The bracketing that will hold the cylinders, the same bracketing as we use for heavy vehicles and generators. These cylinder brackets are ASA ISO approved for hydrogen cylinder restraint. And yet again, following the global hydropower technological system, we have a venting system that if at any stage the cylinder needed to vent, now the cylinder would only vent in a case where it has exceeded 5 times its internal capacity expansion. The cylinders can be left out in the heat up to 575 degrees before the gas becomes unstable. The cylinders do like altitude. Hydrogen likes altitude, so there's no problem with the gas freezing at any stage. Hydrogen's more comfortable in a colder environment. Should, however, there be a need for the cylinder to vent, then the venting system will be through a hose. The cylinder will automatically vent out through a hose out into the atmosphere. If there was to be a venting requirement of the cylinder, that takes place automatically. The cylinders are designed to vent. If they feel that the cylinder internally has reached a pressure where it needs to vent, that will take place automatically. The cylinder will empty what it's holding within a matter of 15 seconds. So it vents completely for safety. With hydrogen, the benefit of hydrogen, it cannot be ignited without a controlled environment. Hydrogen's an innate gas. Hydrogen needs to be contained. It needs to be contained completely, and 14 parts oxygen to 1 part hydrogen with an ignition point. If hydrogen was to be vented, it will automatically raise to the atmosphere, and it will raise 3 times faster than helium. Hydrogen is a very, very safe gas, perhaps one of the safest gases because of its nature to rise. In comparison to other fuels that like to lay low, they are the fuels that we need to be very careful with. Global hydropower aviation, utilising the standard technological system for global hydropower in all internal combustion engines. Aviation, yes, a big move forward for global hydropower, an exciting move forward for global hydropower, and one that the process will be commencing and progressing under the control of Global Hydropower Australia